if I have 2x plus 3 over 5 equals to 7, how do you know what to do first? We all know we do the opposite of whatever it is, but how do you know whether we divide, we multiply, subtract, whatever first? It's a little bit of a tricky one, yeah, Trinity? Yeah, you look at the operation.
Yeah, the operation, so plus minus.
Yeah, you're right. But what would I do first in this case? First off, does the order matter?
No. Yeah.
Yeah, it does matter, right? Because if I go, for example, 5 times 2, and then all of that time, sorry, not 5 times 2, 5 plus 2, and then all of that times by 5 is different from 5 times 5, and then all of that plus 2. That's going to be very different, okay? So we know the order does matter, and the analogy is that if you go home, and let's say you get into bed, because you guys don't wear socks in bed, you take off your shoes and then you take off your socks. You don't take off your socks and then your shoes. So order does matter, right? In this case, Rod, did you have something to add?
Yes. Isn't it BODMAS?
Yeah, it's BODMAS, but it's kind of in a weird manner. So if I was to give you a value, so you guys know values of substitution. So if I said, for example, x equals to 3, then if we focus on the left-hand side over here, you replace that with 3. What would you do first? You go 2 times 3, yeah, and then what would you do? Plus 3, and then you'd? Perfect, you guys are already quite familiar with that. When we do these equivalent equations, we do the opposite. We go backwards. So normally divide by 5 would be last, so we do that first. And then we would take away 3. Okay? So that's how we solve something like that versus if I have, let's say, 2x over 5 plus 3 equals to 7. In this case, if I was to give you, let's say, x equals to 4, you'd say 2 times 4, and then you would divide by 5, and then you'd plus 3. So the opposite, we would do what first?
What?
We take away 3 first, and then we multiply by 5, and then divide by 2. So we do the opposite, okay? Are you stuck? Yep. So normally, like I said earlier, if I put, let's say, a number there, you know that you need to times by 2 first, and then you divide by 5, and then you plus 3, yeah? So what we do with equivalent equations is we do the opposite. So first, as in the normal manner, let's say, I times by 2, and then I divide by 5, and then I'd plus 3. That's what we would normally do. To make an equivalent equation, we go opposite. So I start at the bottom, and oops, let's use this one. I have, now first one is plus 3, so the opposite of that is minus 3. And then the opposite of that one is it minus 5? Times 5, thank you very much. And then we have over here, divided by 2. So we do the opposite. Okay, so let's go into an example of one that's a little bit trickier. So let's say I have x over 5 equals to 4. Okay, if I was to put in a value in here, let's say 3 or whatever it is, you'd say 3 divided by 5. So we do the opposite, 3 divided by 5, so not 3 divided by 5, divided by 5, the opposite of that is multiply by 5, good. So I multiply by 5 on both sides. So x divided by 5 times 5 is good, just x. Because if we're dividing and multiplying by the same number, it cancels each other out, and we just end up with what we started with, which is x. And then 4 divided by 5, we just write 4 over 5. That's it. We leave it as a fraction. If you had a calculator on you, you could put it in as a decimal to get 0.8, but that's not necessary. You can just stay with 4 over 5. Do I have any questions with that one? No? All right, let's do one that's a little bit more complex like the one we did earlier. So let's say I've got 2a minus 3 over 5 equals to 3. If I was to give you a value for a, and I said a equals to 3 or whatever it is, what would you do first? Good, you 2 times 3, so you times it by 2. And then what would you do? Yeah, we'd minus 3, so let's say it was 3. We 2 times 3 minus 3, so let's minus 3 there. And then I would divide by 5, perfect. So now let's do the opposite. So where would I start? So I go this way now. Good, times by 5. And then? Plus 3, good. Divide by 2. Good work. So let's do that. Let's start off with the times 5. So I get 2a minus 3, because those cancel each other out. And then 3 times 5 is? 15. Good. Now you'll notice that we need to do a plus 3 to get rid of the minus 3. So I'm going to plus 3 there. So I end up with 2a. If it's minus 3 plus 3, what do I get? Nothing. So we just keep it as 2a. If I was to write it out, I could go like this. Let's do that. And then on this side, I get 15 plus 3. So 2a minus 3 plus 3 is just 2a. 15 plus 3 is 18. Good. Now what do I do? So right now it's 2a, or 2 times a. So we divide it by 2. Perfect. That's our third step, isn't it? So I divide it by 2. And I get a, or 2a over 2 is just a. Good. And 18 divided by 2? 9. So I get a equals to, oops, what do I write? 9 there. Should be a 2. There we go. A equals to 9. Any questions? Yeah. So that's the idea that's behind the entire exercise. So what I like to do is think about what would I do if I was to put in a value for my pronumeral, and then do the opposite for my equivalent equations. Okay.